Hello everyone. I'm Muhammad Asif and founder for Pakistan Catalysis Society. So today I reorganize some content and now I'm going to present the basic purpose of the society and the basics of the catalysis for today. So for now, so far we have almost 10 members in our society. They are regularly joining with our seminars and participating in different activities. They are on the board. And Dr. Hassan Zeb, they are quite busy nowadays, but they will join soon. And these are our activities: weekly seminar and catalysis, weekly seminars on scholarship hunting that I'm going to organize from this week, right from tomorrow at 2 p.m. Pakistani time. And then we are also running research communication with the public on the YouTube and Pakistan Catalyst Society. This is our official channel. And currently we are focusing on different areas: the heterogeneous catalysis and catalytic CO2 conversion, climate change, and global warming. And what are our objective for our this society? This is strengthening the collaboration between Pakistani student with foreign labs. Like as the students who are working in Pakistan, they don't know about what kind of work is going to be done in different international labs. So this is our one of the main objective. And second is Pakistani faculties with foreign experts. So we want to train them and provide some expert insight with by collaborating with the foreigner experts with the Pakistani faculties, that they can teach recent research trends to the students. And third is Pakistani universities with local industries. We will try to build collaboration between the local industries and the local universities, and we will play our role. And this is somehow our biggest one, but we will try on later on stages to connect Pakistani universities with the foreign industries for the uh, funding and some research project and this kind of things. And the most important is like because a key role is played by the common public in the any countries. So if the public do not know the concept and the recent research trends and their consequences, so they will just behave like what they are doing already. So our main purpose is to translate the advanced research and convey in a as simple as possible in an attractive way to the common public, that they should understand and they can take measures to save the environment and to play a positive role in the society. And for current focusing area is improving communication skills. For us, of course, we are new and we are one of the most important thing is our self training and gaining expertise. And second most important is helping Pakistani student in research and in scholarships. This is from start, and they all other, like previously I discussed, they are our objective for our next 10 or 20 years. So we will work on that, and maybe this is enough for my whole life. Like I will achieve these goals as much as possible. I will try to achieve them in my life, and after that, someone maybe can continue it. And in weekly seminar, so weekly seminar, our model is like we have two sessions of 40 minutes, and more concisely, we can have a 30 minutes talk for the speaker and 30 minutes we have a discussion, because discussion is the most important point in any seminars, that usually given a less time, like 20% to 25%, but in our platform, like we will give enough time for the discussions. Even if it's not enough, so we can extend to another session of 40 minutes, and we can have enough discussions to exchange our knowledge and this kind of things. So this is most important point for our weekly seminars. And the persons participating person can present about the basic concepts, catalytic material synthesis processes, characterization techniques, and current issues, suggestions, or comments. Recently, what we have a problem like facing in Pakistan, smoke problem and some other problems. So this kind of problem can be presented and can be discussed here at this platform. And depending on the expertise of the presenter and researchers, they can select any part and they can present and teach and train other students. And second is anyone can help a course related to catalysis on his domain and can teach other members. So first, I am trying to design one short courses that I will try to share with my team members, and then we can design a different short courses on photocatalysis, thermal catalysis, reactor designing, and some characterization technique and this kind of things. And after the training from this platform, so we can spread these courses with the new students in Pakistan and some other countries, so we can conduct these kind of short courses. So this is also one of the agenda of our weekly seminars, so we can discuss about these points in the weekly seminars. And second, why we select society name as a Catalyst Society for Pakistan. So as we know that like Catalyst uh, leads catalyst leads to faster, more energy efficient processes. This is basically in the chemistry, but I transformed this information, this definition into the like general concept. So catalysts also have a key property called selectivity, by which they can direct the input energy to increase desired positive results. So if we are very selective and we put our energy in the right direction, and we can just activate the already existing processes, so they can be progressed in the positive directions. And we want to play a role as a catalyst, so we will consider ourselves just like a catalyst to play a positive role in the society. First is in Pakistan and of course in the whole world. So our aim is sustainable, renewable, and carbon neutral society. So this is our main focus, and we will play as a role as a catalyst because usually the catalyst is in a small amount, but it can alter the overall reaction dynamics in the chemical reaction system. So if we even we are now we are 10 people, so if we act like a catalyst, so we can actually activate and we can change the thinking direction and performing direction and even the progress of many processes that already existing in Pakistan and other countries. So our role is similar to the catalyst. That's why this society name is Pakistan Catalysis Society. So now I will talk about from the basics of the catalysis. Like so, basically, this I am designing this course for the my new members that background whose background is not related to the catalysis. So I will present one by one the basic concepts and from the advances like how they can build their knowledge in the catalysis and they can connect their field with the catalysis and play a positive role with our society and also individually in the for the as Pakistani society and for international society. So basically, what is the catalyst? Catalyst is something that speeds up the reactions. This is one definition, and the second is catalyst is here like this is the activation energy for the here reactant. Here is a product, but reactant must have to pass through the activated complex. This is called the activation energy. So what is the role of the catalyst to make ease for the reactions it should happen, so it decrease the activation energy for the reaction. So what would be the our role in the country and in the society, and also our the role of the catalyst will be to reduce the activation barrier between the input energy and the output energy. So this is a brief concept for the catalyst. So catalyst basically increase the rate of reaction by lowering the potential barriers during that processes. So what is the basic type of catalysis? So catalysis are homogeneous catalysis. So homogeneous is word is derived from the like catalyst and the reactant both are present in the same phase like gas phase reactions. Catalyst is a gas and reactant is also gas. Solid phase, liquid phase. So it should be reactant and the catalyst should be present in the same phase. And usually it proceeds through the intermediate reaction intermediates, and it occurs most of the time in liquid phase or most of the time, but it's in the gaseous phase reactions. Other is a heterogeneous reaction catalysis. That catalyst basically reactant and the catalyst is present in the different phase. Like our catalyst phase is solid form, so reactant may be liquid and gas. So this will be the heterogeneous catalysis. And for a heterogeneous catalysis, basically the reaction is take place at the active sites, and this is the most important. And I will elaborate about this concept. So what is active site? And in a consecutive sessions, I will explain how we can measure the active sites and this kind of. through different advanced technologies. So basically, gases are adsorbed onto the surface on the active sites, and then they make some weaker bond. Weaker bond may correspond to the adsorption process, and then it can be converted into other products. And then what is basically the homogeneous catalysis? There is one examples. So this is the ozone layer depletions. This is totally as catalyzed by the homogeneous catalysis. And the catalyst here is a chlorofluorocarbons. And here like chlorine, atomic chlorine act as a catalyst, and initially it start the reactions, and at the end it convert ozone into oxygen, and again catalyst is regenerated at the end. So this is also one definition of the catalyst. Catalyst speed up and propagate the reactions or decrease the rate of reaction, but at the end of the reaction it remains unchanged. So as chlorine is involved from here, at the last step chlorine is successfully separated, and it can destroy more than 1 million ozone molecules, but it at the end it remains unchanged. So this is one famous example for the homogeneous catalysis I picked from some high school books. And this, of course, is heterogeneous catalysis. This is our focused area. So in heterogeneous catalysis, so basically there are three main concepts in every catalytic process, basically. So first step is this our reactants. So first step is the adsorption of the reactant. If there is no adsorption of the reactant, so no catalytic reactions. So this adsorption basically dictate and predict the reaction pathway. So this adsorption strength is very, very important. So reactant is adsorbed and other reactant is adsorbed. So here this is a surface reaction, and after the surface reaction, so product is formed, like one reactant from here and one from here is get converted into the product. So first step is adsorption. So adsorption is the most important step in the catalytic reactions, and second is a surface reaction in which different surface intermediates can react with each other and to form a new product. And then, of course, third one is desorption of the product. So if there is no adsorption, no reaction. If there is a weak adsorption, maybe no reaction. If there is a too strong adsorption, it means this molecule adsorbed here cannot go to the surface reaction, then of course catalyst cannot perform better. And second, most important is desorption. So if the product is most stable on the surface of the catalyst, so it will not leave the empty space for the new incoming molecules. So no reaction overall. So adsorption strength basically dictate the rate of the reactions and also the product selectivity during the catalytic processes. So they are the most important, so we have to measure them. And second is product selectivity. So even though we are same reactant, we have uh, same reaction conditions. If we use a different catalyst, so product will be entirely different. So like here we have a methanol, and here we also have a methanol. So here we are using a copper catalyst. If we use a copper catalyst, it get converted into the aldehyde. But if we use alumina, so this is converted into the acetylene. So this is how the catalysts work in reality. So what is the reason? So in that the active sites are the same distance apart as the length of the OH bond. So this bond will break and then H2 molecule will be formed. But here this CO bond. So CO bond length is exactly the same, the distance between two active sites. So oxygen will adsorb here and carbon will adsorb here. Then this bond can be broken and oxygen can be removed. And then this OH will remove from here. And then OH can catch one hydrogen from here and it will become water. So this is how even same reaction conditions, same reactant, but if we use a different catalyst and they have a different properties, the product will be entirely different. And then what is the science in the catalysis basically? So in catalysis, we have a concept like to increase the surface area that provides more active sites in a sport medium. So we have to maximize the surface area and reduce the cost. But the problem is like high surface area correspond to high catalytic activity. This is a big question. So whenever we are talking about the surface area, so it's always not true that higher the surface area will have a higher catalytic activity, because then what is the most important thing that dictates the rate of the reactions? So for that, we are going to for next slide. So basically here I want to introduce you the concept of the active materials and active site. And basically this is concept for the active sites, but first I want to introduce the concept of active materials. So what kind of materials are active for which kind of reaction? So here we have a CO2 molecules and here we have ammonia molecules. So in ammonia we have electrons here, but in a CO2 molecule we do not have electron in the central atom. So what kind of catalyst we need for to run this reaction? So here basically this is electron withdrawing, so it needs some electrons. So if we provide electron here, so repulsion between these electron and these electron will be higher. So this O will become here and here. So this angle will be distorted and artificial polarity will induce and it become reactive. But for that molecules, this is electron donating. So here already electrons are there, so they repel this hydrogen and hydrogen here. So that's why this is already distorted molecule. So for that kind of catalyst, for that kind of reactants, we need electron donating catalyst. Like we can select from the alkali metals or alkaline earth metals that can donate the electrons to propagate that kind of reaction. For this kind of materials, for that kind of reactant, we need electron withdrawing. So the catalyst that can extract electron from the reactant that make perform better. So both molecules can be adsorbed on same material? No, because if we have electron donating or electron withdrawing nature, so the adsorption pattern and adsorption process will be totally different. Because if there is electron withdrawing, this molecule will not adsorb, but this molecule will adsorb and vice versa. So we have to be very careful, like when we are starting a new field and new material, and we want to check uh, what kind of catalyst will work for that. So first we have to study the electronic property of the materials, and then we have to select the opposite electronic nature of the catalyst, and then we can uh, design some proper catalyst for the its reactions to occur at a lower or mild conditions. So here I want to introduce what is the active site. Basically, I got two definition, one from Science that published in 2012. The active site of heterogeneous catalyst can be thought of as the ensembles of atoms that directly catalyze a reaction, like the reactant that directly adsorb on the site. This will be the active site. From a nature, it was a surface steps caused by the stacking fault or twin boundaries in a copper nanoparticle are key to activity of the methanol synthesis. This is an examples. So here, basically, this is a catalyst particle that is drawn by the Blender software. So we can see these are different sites are there. So they are differentiated by different colors. So each site is not active for our desired reaction. So a specific site is active for our reaction. So we need to select a material and synthesize a material in such a way that so we can have a maximum number of active sites that we desired basically. So this is a concept, like if we have only this is active site, so we will prepare a material in such a way that this site should have a maximum in numbers. Same as in a biological sciences, the active site is that part of an enzymes or other proteins where a reactant or a effector can bind. Basically, this correspond to the adsorption step where the reactant molecule will go and adsorb. This will be the active site for that reaction. Take part in a catalytic transformations. The active site will usually only binds specific molecule and is therefore highly selective. So if we have a catalyst and active, we have a like even case of CO2. So if it will only attract CO2, it will not attract to any other molecule. So they are very selective, and we need to have a maximum number of active site in our catalyst to get a higher yield and higher results. So these are two papers that so far I took help from them, but one by one I will present to you at a later on stage, and they are very famous scientists in the field of the catalysis. and a small amount of data I collected from these papers. And then first we have this, if we decided the active site and we found that this is the active site for this reaction, this is a very good area people always publish in Nature and Science, that how to find the active site from the catalytic materials. And then we can basically see the turnover frequency. Basically, what is the turnover frequency? So if we consider in our material, if there are 1 million active sites, and if we consider one active site, so in one active site, in 1 second, how many molecule will be absorbed and transform into the product? So this is a turnover frequency with respect to per second and per hour. So basically, turnover frequency will be the number of molecules uh, get converted on a one side in unit time. Unit time we can decide whatever it may be. So this will be the turnover frequency, and this that dictates the rate of reaction. And then there is a turnover number. So number of moles of a substrate that molecule can that this is basically number of molecule of a substrate that a mole of catalyst can convert before becoming inactivated. So this is turnover number. So this is basically like one active site can perform how many molecule can be converted on one reaction before its deactivation. So if it deactivated in, so usually people um, make a mistake. So I will point out it later. And but this is what I want to define the definition of turnover number. So in a uh, activated period, so how many molecule can be converted into the product over one active site? This will be the turnover number. And then is a lifetime of the catalyst. Lifetime of catalyst is measured in a turnover numbers before its deactivation. Or this will be the lifetime. It's not in the hours or some time. And then amount of the product we obtain from 1 gram of the catalyst. But again, this 1 gram should be, usually people report space-time yield in this way, like 1 gram, but yeah, 1 gram of catalyst always do not have a same number of active sites. So active sites are always different. So we have to report with the active site. So this may be a good way, like we can represent our data in term of turnover frequency, turnover numbers, or lifetime of the catalyst. This may be. And then I wanted to point out some of the misconception in the field of the catalysis. First is people always think the surface area correspond to the activity. When they plot some BET surface area graph or some other graph, so they always think why surface area is increasing, but product selectivity is decreasing, or rate of reaction is decreasing. So this is not a case for the surface area, basically, because our reaction is not performing on the each side. They are performing on the specific side. So we have to be very, very careful and determine and to find which is the active site and how much is the active site area. And that basically will be correspond to the rate of the reaction. And then catalyst life. So usually people report in 2000 hour, 3000 hour, 1 month, several months, this kind of discussion. But again, this is not a proper way to present the data. So we have to present in turnover numbers. Like a molecule can be deactivated after converting 10 molecules, 20 molecules, 1 million, 2 million, 3 million. This kind of data is most scientific. And this is a common misconception in the literature, except some good journal like Nature, Science, or some other journals. Other journals just follow this myth. So what's the most important part to understand the catalytic processes? The understanding of the active site for specific reaction product, selective synthesis of these active sites, and we have to minimize the other catalytic sites. If we will minimize other active catalytic sites, of course, comparatively, we will have a increased number of the active sites that we are desired, and then how we can measure these active sites and so on. This will be the topic for my next few presentations that I will present about this kind of things, like how we can measure and how we can determine through different experimental techniques. We can use temperature program methods and BET, of course, we can consider. And then we have some other probe molecules, and we can insert these molecules, and then we can see how many number of active sites are there in a 1 gram of the catalyst. and then we can see the total amount of the product, and then we can divide and we can see what is the turnover frequency and this kind of discussions. So I found a very interesting paper that published in Nature Chemistry. This is promoting active site renewal in heterogeneous olefins metathesis catalyst. So this is very important. So this was published from one famous group from at MIT. So I will present about this paper, and previously I mentioned about two papers. So I will summarize them, and then we can have some clear idea. But the next point for my presentation will be how can we measure the exact number of active sites through different characterization techniques with its working principle, and how we can analyze these data and we can get the exact number of active site, and we can measure the rate of reaction in catalytic reaction. And this will be equally useful in photocatalytic reaction, and also in thermocatalytic reactions, and also in electrocatalytic reactions, because this plays a very, very important role. And being a student of the catalyst, and as we are a member of the Pakistan Catalysis Society, so we should know about the basic concepts and how we can apply in the field and how we can determine. Of course, I will cover a few characterization techniques, and also some softwares and some other stuff, how we can exactly find these kind of concepts, prove them, and plot them in a beautiful figures and present in the papers. So thank you so much, and for your attention and listening this talk. So I think we will terminate this session here, and soon we will start another session for question and answer and discussions. So I hope see you all within few minutes in next sessions. Thank you so much.